In this video, you're going to be learning about mole-to-mole conversions. Essentially, what that means is if you have a reaction happening, can you predict how many moles you need to get a certain quantity of product, or can you predict how much you're going to produce based on how much reactant you have? So it allows us in a laboratory to sort of specialize in getting an experiment that gives us the quantities exactly of what we need, as well as use the quantities that we have available to us. So we have this chemical equation. We see that we have chemicals coming together to produce solids. And in this equation, it tells us the ratio. We know that we have, for every 1 mole of aluminum nitrate, we need 1 mole of sodium phosphate, and it'll produce 3 moles of sodium nitrate and 1 mole of aluminum phosphate. But what happens if, in the real life scenario, you don't have 1 mole of aluminum nitrate, but instead you have 2 moles? That's what I'm giving here as a given. If I have double the amount of aluminum nitrate and I have plenty of sodium phosphate, so this piece we're going to just sort of ignore because we have more than enough. So let's just focus on the number. How many moles of sodium nitrate are going to be produced? Well, for most of us, if we kind of think on our head, well, if I have double the amount of aluminum nitrate, wouldn't I produce double the amount of sodium nitrate? Wouldn't it be 6 moles? And the answer is yes. Okay, remember these are ratios. So in chemistry, we use dimensional analysis to calculate through those, and that's what I want to show you. So previously, you've learned about creating conversion factors based on 2 mole relationships. So the relationships we're looking over here are for aluminum nitrate, and I can always tell which relationship it is based on the one that has the number. This chemical doesn't have a number in front, so we'll just ignore it. We're just saying we have plenty of this sodium phosphate. We don't need to worry about it. And we're also looking at how much NaNO3 is produced. So the first thing we need to do is look at the ratio. So we know that for every 2 moles of AlNO3, it will produce, let me repeat that and erase that. For every 1 mole, the reason I'm putting 1 on here because I'm looking at the chemical equation, so my apologies. So my chemical equation tells me for every 1 mole of aluminum nitrate, that means that I will produce 3 moles of sodium nitrate. So the next step is creating those conversion factors. So that can mean that I have 1 mole of aluminum nitrate on the top with the 3 moles of sodium nitrate on the bottom. Just a reminder, remember I'm using the chemical equation to determine this ratio, not my question that I am trying to answer. So you use the chemical equation. I can also set up the conversion factor to be 3 moles NaNO3 for every 1 mole of AlNO3. Okay, so those are my conversion factors. So what I'm going to do is just like we've done in dimensional analysis, I'm going to record what my given is. So in this case, I'm told that I had 2 moles of aluminum nitrate. Where did I get that value? I got that right over here, okay? And I put a times sign, and now I need to use the conversion factor that allows me to cancel out moles of aluminum nitrate. So just like we've been doing before, we need to make certain whatever is here is at the bottom, and that would be this conversion factor. It allows me to cancel things out. And this is why labeling is always so important, especially now with chemical formulas. So with that said, I'm going to check whether or not these things cancel out. Moles cancels out, but also the aluminum nitrate cancels out. Then I just times 2 by 3 to be 6, and then divided by 1. That means 6 moles of NaNO3. And that's exactly what we predicted. Remember, we said, well, if we have double the amount of aluminum nitrate, then we'll have double the amount of NaNO3. Double the amount of 3 is 6. All right, so now let's try one more like this. We have the same chemical equation, but now I'm given that in a reaction, 0.5 moles of AlPO4 is produced, so half the quantity of what our equation says. And I want to know how many moles of Na3PO4 were used to get just half a mole as opposed to 1 mole. Now, many of you might be looking at this and just already in your head being able to say, well, if I only have half the quantity of AlPO4, then I need to have half the quantity of Na3PO4. Wouldn't the answer be 0.5 moles? And you're right, it is 0.5 moles. How would we show that in chemistry? So we would show that by looking at the relationship of Na3PO4 with AlPO4. So we see from our chemical equation that for every 1 mole of Na3PO4, we are going to produce 1 mole of AlPO4. So this allows us to create conversion factors. Be sure you label those conversion factors both with units and with the chemical name. I can flip it around as well. I have 1 mole AlPO4 and 1 mole Na3PO4. Okay, so I'm going to set up the equation. The way that I do that is always start with what I'm given. So in this case, what I'm given is this value right here. So I'm going to go ahead and write that down. I have 0.5 moles of AlPO4. I'm going to times that by a conversion factor where I make certain that I can cancel these out. That means I need to have moles of AlPO4 be at the bottom, and that's this conversion factor. So I write down 1 mole of Na3PO4 over 1 mole of AlPO4, and that works out to be let me make sure I cancel those things out to make sure that I've got it right. 0.5 moles of Na3PO4. Okay, so those conversion factors and that dimensional analysis allows you, without to do a whole lot of thinking, figure out the proportions of what you need. So we're going to try a couple of more. I'm going to go ahead and stop these where now I'm going to have you try it, and then I will give the answer. So go ahead and stop the video, try this one, and then press start again when you're ready to see the answer. Check whether or not this is the answer that you've gotten. Remember, you're always creating these conversion factors from the chemical equation itself, not from the actual question that I'm asking. Let's try one more. Same thing, go ahead and try this one on your own. Put it into your notes. Stop the video now. Did you get this as an answer? Again, always check to make sure that your units cancel out. And the answer works out to be 0.5 moles of LiNO3. And that's it.